The last improper integration video for now. And these are kind of the worst ones where you have a function, 1 over x minus 3 to the 4th in this case, that's undefined somewhere in the interval, but it's undefined at the point that's not one of the endpoints. And this is undefined at 3. So what we have to do here is break it up as an interval from 2 to 3 of 1 over x minus 3 to the 4th, plus the interval from 3 to 5 of 1 over x minus 3 to the 4th. Now I'm pretty sure that this one's going to diverge, because when I integrate 1 over x minus 3 to the 4th, I'm going to get something over x minus 3 to the 3rd, right? Because you add 1 to the power. And if you plug in 3 to 1 over x minus 3 to the 3rd, you're still going to get division by 0. That doesn't mean we can't not do the work, though. So when you're integrating, when you're doing improper integrals and you have 2 different integrals, you just do one of them. And then if it converges, you have to do the other one. If it diverges, you get to stop. Because if this diverges to infinity, it doesn't matter what this does. Even if it diverges to negative infinity, we don't know anything about infinity minus infinity here, so we just say once one of them diverges, the whole thing diverges, which is great. So I'm going to do this one. So I'm going to do the limit as, let's replace the undefined point with t. So as t goes to 3 from the left, right, I'm between 2 and 3, I'm definitely less than 3, I'm definitely left of 3. I'll write this as x minus 3 to the negative 4th. You could do a u sub here, but it's really unnecessary. If u is x minus 3, then du is just dx. I'm just going to treat this like it's one thing and say, okay, this is going to be the integral of x minus 3 to the negative 4th is x minus 3. Add 1 to negative 4, you get negative 3 divided by negative 3. From 2 to t. I'm going to rewrite this a little bit. It's the limit as t goes to 3 from the left. Negative 3 doesn't come up. You can move the negative on top or on, but the 3 has to stay on the bottom. So I'll write this as negative. Right, 3 on the bottom. I'm also going to bring this down, right, as x minus 3 to the positive 3rd. Because I like positive powers. And then I need a 1 on top just because I divided everything else away. You can write this as negative 1 or negative 1 over that. From 2 to t. And you can see that if I plug in t, so I get negative 1. Sorry, that's negative. My negative's a little too big there. Let's see, I've got t minus 3 cubed minus negative 1 over 3 times 2 minus 3 cubed. This is going to be like 1/3 or negative 1/3. This here, as t goes to 3, 3 minus 3 is 0, 0 cubed is 0, 1 divided by 0, that diverges. So this is going to diverge. And if I was, well, in fact, so here's the thing I can't say. I know that this part here, let's say if I plug in 3 from the left, this is smaller than 3, so this part's negative. It's a negative and negative, so it's a positive. So this part diverges to positive infinity. But I actually don't know, and I don't want to know what that part, I don't want to do the work anymore. So I wouldn't say this one diverges to infinity. I don't think it does. I think this part actually goes to negative infinity. And when we add them together, it's unclear. I would just say this thing diverges and leave it at that. So again, I don't have to do the other piece at all, because once one piece diverges, the whole interval diverges. Let's look at this one. Also terrible. Definitely undefined at 1. I also want to make it clear that it's perfectly fine for x to be 0 here, right? 0 minus 1 is negative 1, but the keyword of negative is perfectly fine. So let's do the integral. So let's do this part first. We do the limit as b approaches 1 from the left of the integral from 0 to b of, I'm going to write this as x minus 1 to the negative 1/3. So the limit as b goes to 1 from the left. Integrate that, you get x minus 1 to the, add 1 to the power, you get positive 2/3. Divide by the new power is like multiplying by the reciprocal, which is 3/2. From 0 to b, get the limit as b goes to 1 from the left of 3/2 times b minus 1 to the 2/3 minus 3/2 times 0 minus 1 to the 2/3. Plugging in 1 minus 1 is 0. 0 to a positive power is perfectly fine, it's just 0. So this whole part is 0, and this part is negative 3/2 times negative 1 to the 2/3 power is just 1, because negative 1 squared, which is positive 1, and the cube root of positive 1 is 1. You can also say it's negative 1, cube root of negative 1 is negative 1, and then negative 1 squared is 1. So this piece converges to negative 3 halves, which means we have to check the other piece. If the other piece converges also, we're going to say the whole thing converges to their sum. If the other piece diverges, we say the whole thing diverges. So luckily we've already done the integral, so we can say, okay, well the other piece is going to be the limit as a approaches 1 from the right of the integral from a to 9 of 1 over the cube root of x minus 1 dx. And we know how this integrates, right? It's this. It's 3 halves x minus 1 to the 2/3 from a to 0. Sorry, a to 9, apologies. Then we're going to plug in. We get 3 halves times 9 minus 1 to the 2/3 minus 3 halves times a minus 1 to the 2/3. And when we plug in 1, we get 1 minus 1, which is 0, to a positive power. That's just going to be 0. So you get 3 halves times 8 to the 2/3. And 8 to the 2/3 is the cube root of 8, which is 2, squared, which is 4. So I get 3 halves times 4, which is 3 times 2, which is 6. So my final answer is that it converges to negative 3 halves plus 6, which is negative 3 halves plus 12 halves, which is positive 9 halves. Fun times.